well, right? Yeah. So, ladies and gentlemen, so my name is Lê Thanh Hiền. I'm the lecturer of Faculty of Animal Science and Veterinary Medicine in Nông Lâm University. And now I'm very happy to be a monitor for the workshop today. So as you know that the COVID-19 is become very worse today and nowadays, but we keep talking about them, but today let's take a little break to talk about something different. Today I want to welcome all of you to the workshop organized by Nông Lâm University in Ho Chi Minh City of Vietnam and collaboration with Ghent University in Belgium. So this is an activity in the very big project. The name of the project is exploring the impact of foodborne parasites on food safety in the south of Vietnam, which is funded by Belgian government. So we designed a workshop to raise the awareness on zoonotic parasites in terms of their importance in the communities and to share the experience and also techniques to detect those kind of parasites. And finally, we can, during the project, during the workshop, we hope that we can meet together to collaborate and to work together to deal with these problems. So that is the purpose of the workshop today. So before we start, may I have some minutes to introduce our guest today? Because we have not so much time, so I want to prepare the short presentation for introduce the guest. So firstly, I would like to introduce Professor Toàn. He is Professor Nguyễn Tất Toàn. He is a Vice President in Nông Lâm University in Vietnam, and he will have a short talk later on. And second one, I would like to introduce Associate Professor Lê Quang Thông. He is Dean of Faculty of Animal Science and Veterinary Medicine in Nông Lâm University. And we also have a very important project promoter in University of Ghent. So Professor Sarah Gabriel. She is parasitologist and an expert for the project and also the promoter for the project. And in Vietnam, so my name is Lê Thanh Hiền, as I mentioned before, I'm also the local project promoter. And I would like to introduce Dr. Đào Thị Hà Thanh. She is an expert in the parasitology in Vietnam, and she works for National Institute of Veterinary Research. And today she is an invited speaker, and she will talk more about what is the situation of parasites, zoonotic parasites in Vietnam. And I also want to introduce Dr. Đường Chi Mai and Ms. Dương Tiểu Mai. So both of them are the lecturer in our faculty teaching parasitology. And so that is the team of the Nông Lâm University and Ghent University. So during the workshop, we want to invite people working in other organizations and also in the government sector to meet together, and we have the panel discussion. So I would like to introduce Dr. Phạm Đức Phúc. So he worked for, he's the chair of the network, we say Vietnam One Health University Network. And Dr. Nguyễn Văn Dũng, he worked for Sub-Department of Animal Health in Ho Chi Minh City. And Professor Nguyễn Duy Phong, he is a professor in University of Medicine and Pharmacology in Ho Chi Minh City. So we can see during the final discussion, so how we collaboration and what is the responsibility of each organization in terms of the responsibility to control the disease, zoonotic disease, parasitology in Vietnam. And most important is the participant in the workshop today. So you make the workshop a success. So that is the guest in the workshop today. I want to give a little more, information about the agenda for this workshop. So first, I will invite Dr. Tuan to have some welcome speak from Nông University. Welcome everybody to the workshop. And next, we will have the key lecture from Professor Sarah Gabriel from Ghent University. So she will mention about the importance of parasitic zoonotic disease in the world. And the next one is the talk given by Dr. Đào Thị Hà Thanh. As I mentioned before, she will have the picture about how the parasite infection in Vietnam. So what is the most important parasite in Vietnam can transmit from animal to human. And the next one, we will have the technical sharing from the team of Nông University. So we work in the detect the parasite from animal tissue, and Dr. Mai and Ms. Jim Mai will share how we work with in Nông University. So that is just the sharing experience and sharing knowledge. And the last one, we can have the panel discussion with our panelists and everybody. Okay, so that is the agenda for today. I hope that we can spend about 2 hours, not more than 2 hours for the workshop. So the first one, I would like to invite Dr. Toan, Professor Toan, to turn on the microphone and just give the welcome speech to everyone who go to the workshop today. So please, Dr. Toan.
Okay, yes, thank you. Thank you very much, Associate Professor here. Everybody hear me? Please?
Yes, I hear very well.
Okay, yeah, okay, yes. Good evening, everyone. Dear distinguished guests, ladies and gentlemen. I'm very happy to be invited to give a welcome speech for the workshop with many participants from many countries. As you know, Nông Lâm University Ho Chi Minh City is a leading university in agriculture in Vietnam. It has a long history of international collaboration to do scientific research and technology transfer with the aim for sustainable development of the country. In this mission, we have many collaborations with Belgium government, supported by many projects bringing value for our community. Among those, the project exploring the impact of foodborne parasites on food safety in South Vietnam, with the cooperation between Nông Lâm University Ho Chi Minh City and Ghent University, Belgium, is aimed to understand the current risk of the foodborne parasitic disease that helps to ensure food safety, especially animal origin food. One of the public activities of the project is to help people to know more about the continuous risk of parasitic zoonotic diseases in the area of viral infection, and we should not neglect to the purpose control and prevent them sufficiently. The project are ongoing in Nông Lâm University with the support of experts from Ghent University, Belgium. I hope that expertise from speakers and some experience from Nông Lâm University Ho Chi Minh City team can be useful for all participants tonight. In addition, the responsibility of control disease might not be belong to teams or designated people, but it is for all people and organizations. That is why I bring everyone here to discuss how to collaborate to do better in One Health concept. Last but not least, I wish that the workshop will be very successful and fruitful discussion. Wish you all the best, protect yourself and the community. Thank you very much for your attention.
Okay, so thank you, Dr. Professor Toan, for the very warm welcome to everyone. So now we go to the main point of the workshop. So I would like to invite Professor Sarah Gabriel. So she will have the presentation about the picture, the whole picture of the world about importance of parasite, parasitic zoonotic disease. So please welcome Sarah.
Okay, thank you very much. Can you hear me?
Yes,
Yes.
clear.
Yes, okay. And can you see my full screen shared? So you can see the full presentation?
Yeah.
All right, perfect. Technology follows. That's already something, right? Okay, first of all, I'm really happy to be able to present during this workshop, and I'm really happy to see so many people who are attending this workshop. I think the parasites are important, so it's a really good thing that we have such a large audience on this workshop. So thank you very much already in advance. So I will explain a bit about the importance of foodborne parasitic zoonosis. And with that, I actually want to tackle a bit the question. I mean, these diseases are neglected, but are they really negligible? But first of all, I would like to spend a few words on what are foodborne parasitic zoonosis, because there's quite some differences with bacterial infections. In the first place, so on the foodborne side, very often the parasitic infections are meat-borne or fish-borne or reptile-borne, for example. But these infections happen pre-harvest. So when the animals arrive at the slaughterhouse or when the animals are slaughtered, the infection is already there. So with the parasites, it's much less that you can, for example, contaminate the one carcass with the other, or that your pathogens will start growing and multiplying because you're not respecting the cold chain, for example. Your parasite is already present. The cysts, the larvae are already present in the meat, for example, and they will not start multiplying because you are keeping your carcass above 5 or 6 or 7 degrees. They will be there and you will not be able to control them. You would have to freeze or heat to really kill them. So a lot of these infections are already present in the meat or in the fish, but of course, these parasites have very complex life cycles with multiple stages. You will have adult stages, you will have larval stages, but you can also have stages that are excreted into the environment by one of the hosts, for example, with the stool or with the feces from an animal. And these eggs or oocysts or cysts, they will contaminate the environment. And by contaminating the environment, they can then contaminate food or water. So we say foodborne, but it can also be waterborne, and it can already be present in the food, depending on the stage of the parasite, or it's an environmental contamination, and then you can have food in a much larger sense of the word. It can also be fruits or vegetables, water, which is then contaminated. And depending on which stage of your parasite that is infectious to human, this environmental contamination will be more or less important. It's also much more difficult to control, of course, and then the survival of these stages in the environment differs a lot between parasites. So unfortunately, all these parasites also have very complex life cycles, difficult to understand and difficult to remember all of them and to differentiate them, because they're quite substantially different sometimes, the one from the other. Another point is that the zoonotic importance of some of the species is not always well known or well described. So your source attribution is not always that easy. For example, in Giardia or Cryptosporidium, you will have cases where the outbreak is due to an animal source. But like in Europe, we will have even more cases where it is in fact a human-to-human transmission. So it is still a parasite, but the source is not with the animal. With lots of others it is, but it's again a mixed story. Now, are these infections important? Foodborne infections in general have had increased attention in the last years, and I think that's very good. I do think that we should always ask ourselves the question, is it really an actual increase in number of cases, or are we more aware? Is there improved detection? because we still see that with parasitic diseases, the diagnostics are a problem. We always have difficulties with our tools. They don't work very well very often, but there is improvement. So is it because we use better tools that we have more detection? Is it because we use more tools? Is it because we're more aware, that we have more knowledge about it, so that we know more? And then there's, of course, also the improved communication. With the social media now, whatever happens in the world, wherever it happens, we will all know it. So not only the academics, the researchers, or the people in the medical sector or the veterinary sector, not only they know what's happening, but it's like the whole world knows much more rapidly what's happening. So also your general population is much more aware of foodborne diseases, which again leads to better health-seeking behavior and more detection. Still, these points aside, we do think that there is an increase in foodborne diseases on a global level. What we also see is that in the foodborne diseases, most attention still goes to the bacterial diseases, and these are very important. Parasites get less attention, and the question is that really correct that they should get less attention? Like this tapeworm is wandering also. It is changing over the years, and WHO together with FAO and also OIE, they have been working more on it. And there has been actually an assessment of the burden of foodborne diseases by a group put together by WHO. And they looked into the disability adjusted life years, the DALYs. And as some of you will not be familiar with the DALYs, I will very shortly explain. The DALYs, they are a measure of disease burden. And it's actually a system to be able to compare different diseases in an objective way. And a DALY actually represents the years of life lost on a population level to a certain disease. So how many people die earlier than they were supposed to be, than the general life expectancy, but also how many people live how many years unhealthy, so with a disability. And these are all factored in. And the disabilities can be very wide. It can be epilepsy, but it can also be diarrhea, it can be headache, it can be whatever. But they calculate this for every disease. And so for every disease, they join the years of life lost and the years of life lived with disability on a population level. And in that sense, they can kind of estimate the burden in a more objective way and compare the burdens of different diseases. Now, what is important here is that this is a selection of the 31 most important foodborne pathogens and the burden of these diseases. So this is on a purely human level, okay? We don't take any impact or cost on the animal level into account when these calculations are made. And so what we see here is each time for each disease or each pathogen, the burden in disability adjusted life years expressed. Now, I'm not going to go much more in detail of this graphic, but what I want to emphasize here is that 14 of these 31 most important foodborne pathogens on a global level are parasites. And yet, very often, the only attention goes to the bacterial diseases. What we do see in these parasitic infections is that they cause mostly chronic diseases. Again, not always. It's not a black and white story, but there in this graph, you then see that the dark blue is the years lived with disability. So some kind of disability caused by disease and caused by a chronic disease. And so on this side of the figure, it's mostly parasites. So they cause a burden but very often it's a chronic disease. Not always. Like with Echinococcus multilocularis, we do have an important level of mortality. Here we see a different type of ranking. The previous one was a calculation. In fact, this is more a scoring system which was conducted by experts. But still we see, for example, that Taenia solium, the pork tapeworm, is the absolute #1. We will come back to that later. Now, looking a bit more into numbers. What am I saying? Why are these foodborne parasitic infections important? Well, in these tables, again, calculated by the Global Burden of Disease, Foodborne Diseases Group, the FERG. In these tables, you see each time in a column the, can you actually, like this, you can see my cursor. Here, the foodborne illnesses, so how many people were ill, were sick because of these pathogens, and here we see the foodborne deaths, and each time for the different groups of parasites. So in general, for the helminths, we can see that almost 13 million people globally at one point during that year had a foodborne illness due to parasites. If we see at the most important foodborne parasite, Taenia solium, then we do see a mortality of almost 30,000 people every year and 370,000 illnesses. Yeah, in total, we have 45,000 estimated mortalities. As I said before, and I will come back to that, usually there is a huge under-reporting. So Taenia solium is definitely the #1, but we also have the Echinococcus, cause of a lot of foodborne illness, and especially Echinococcus multilocularis, the fox tapeworm, also occurring in a lot of areas in the world. Almost 8,000 people die from this infection every year. Trichinella also present in Vietnam, but here we see more illness than actual mortality. And then when we look more at the trematodes, and then here a lot of fishborne trematodes, more related also to your area, also responsible for quite a number, almost 220,000 illnesses globally every year. So here, if we look again at these DALYs, so these disability adjusted life years, now specifically for the parasitic infections, so here cysticercosis, the Taenia solium tapeworm, is the absolute #1, but here more for your information listed the other ones. I'm not going to go too much in detail, but you do see that there is a difference in disease burden. Now, this is expressed on a global level. And what is important again to realize is that there are important regional differences. And of course, these are related to the occurrence of this parasite in your region, related to occurrence. And this is of course also a lot related to the practices in these areas, the practices, the good practices at farm level, but also then at transformation level in the slaughterhouses, further transformation in the distribution sector and at everybody's home. How good are you implementing the basic food hygiene rules? Now here, for example, in the African region, we see that we have a high burden of these foodborne parasitic infections, and we see here in the pink color that Taenia solium, the pork tapeworm, actually plays a very, very big role. In Europe, after many, many years of very, very strict regulations, we are actually at a very low level in foodborne infections, and you can see the dark blue one, which is the toxoplasma, but it's postnatally acquired toxoplasma. So a lot of us, we have in mind that toxoplasma is actually a main problem with pregnant women only because of the transfer or the potential transfer to the baby. But we see that postnatally, this parasite can cause quite some disease burden as well. Now, if we look more to the region of Southeast Asia, then here it's mainly this block that we need to keep in mind. And we see a bit as expected, a lot of Paragonimus, but also Taenia solium, Clonorchis, of course, related to that burden, the intestinal fluke, Opistorchis, also the Toxoplasma postnatally acquired, Echinococcus multilocularis, but much more to the north of this WHO region. Now, what we do know, for example, that is occurring a lot in Vietnam is fasciola, and yeah, it doesn't really come out here as being important, but of course, these are also estimates of the region. I've added this slide just more for your information. Here you see the explanation for the regions that I used in the previous slide. Now, so we see that there are a lot of foodborne parasitic zoonoses, but we also see that we have an increased risk. And a lot of that increased risk is actually related to what we call globalization. So there's definitely the issue of migration. And I took some numbers here. They're a bit old, but I didn't want to take the numbers from last year because, of course, with COVID, the migration has been reduced, and we're hoping that we're going to get back to a more normal situation. But for example, in 2012, in our European Union, we had 1.7 million immigrants. And then within our European Union, we also had 1.7 migration. So people move a lot. On a global level, we had 16.7 million refugees and asylum seekers. And then, of course, we have this millions of people that migrate illegally and that are very hard to control. We have, in 2012, there was 1/7 of the world population that traveled from one country to the other, from one area to the other. That's 1 billion people. So that's millions, I mean, 1 billion of people moving around across our globe. And these people are potential carriers of parasites. So when they come back home or they go to another country, and that can be all of us, we can not only bring our suitcase, but we can bring a parasite with us, and we can transmit that parasite either to another human being, either to another animal, either we don't transmit the parasite, but we do fall sick. And if that parasite, if that infection doesn't occur in that area, then we're not very familiar with how to deal with that infection. And I think COVID has again proven to us on how rapidly diseases can be transmitted throughout the world. We also have a lot of trade and an increasing amount of distributions. I mean, foodstuffs are flying again all across the globe. And I just looked it up at Faustat this morning. So again, you have millions of tons of meat that you are importing, and that's legally. So that's controlled, or at least in part controlled. So normally that should be safe, or most of it should be safe. But of course, and this was just in one of the journals this morning, there's also a lot of illegal import of meat, which can again be a cause of bringing in not only the meat, but also a number of pathogens. We also have changes in consumer behavior and culinary traditions. For example, with us, we eat a lot more food raw now. And that's just not good for parasites. I mean, we need to freeze or heat, otherwise we don't get rid of the parasites. So we consume a lot more potentially infected food. In a lot of endemic areas, we see that there is an industrialization ongoing in the farms. They're becoming bigger, while in our areas in Europe, we see a bigger trend in animal welfare, going to more biological farming, where we give our animals outdoor access. But for parasites, if you give an animal outdoor access, it's parasite paradise. So you will see an increase in the infection levels in the meat. We also have population changes. We have much more elderly people and they are more susceptible to disease. Of course, yeah, you also have the whole group of malnourished or undernourished people, which are also more susceptible to disease. So all these factors together are actually putting a larger population at risk of parasitic infections. So we used to know very well these are endemic areas and the parasites used to remain in these areas, but we see now that it's spreading and that you put more people at risk of infection. Now, just to say a bit more about two parasites, because my colleague will explain a lot more about the parasites occurring in Vietnam, but I did want to say a word about Taenia solium, the pork tapeworm, because it's the #1 foodborne zoonosis. So how does this worm work? Well, we as people, we have the adult tapeworm in our intestines and we excrete the eggs and the proglottids into the environment. The pig will eat it and the pig will develop what we call porcine cysticercosis. When we eat that pork meat, we get the tapeworm. But unfortunately, we can also get infected with the eggs and then we get cysticercosis or neurocysticercosis. And neurocysticercosis, we get it when these larval stages of the parasite will settle in our brain. And when we get that, this is the most important cause of acquired epilepsy in endemic areas. So we both get the tapeworm and the larval stage, the neurocysticercosis. Porcine cysticercosis is a problem for the farmer because very often he will get a lower price for the meat, and if there would be official meat inspection, all this meat would be condemned and so lost to the farmer. As you can see here on the small map, Taenia solium occurs mostly in the southern part of our world, although we do have cases in Europe as well, but it's definitely also occurring in Vietnam. So just to emphasize this, how do people get infected? Well, we get the tapeworm by consumption of the infected pork. We get a tapeworm, can be several meters long. But what is worse is that we can also get cysticercosis and the neurocysticercosis, and that we can get it by ingestion of eggs. Eggs which can be on the hands of a tapeworm carrier. The tapeworm carrier can contaminate the environment, can contaminate fruits or vegetables or water. This also means that a vegetarian, for example, can get neurocysticercosis because of contaminated environment or close contacts. Another parasite I would like to finish my presentation with is the Anisakidae. These are much less known, and the reasons that they were not taken up in this big foodborne burden, disease burden study is that they didn't have enough data, because this is a very neglected parasite. Here we see that in fact the marine mammals are the final host. They lay their eggs in the ocean. We have larval stages in crustacea, then squid as well, and then in all types of commercial fish, and some fish species are up to 100% infected. People get infected by eating the fish with the third larval stage of the parasite, and we see clinical symptoms related to the uptake of these viable larvae. And depending on where this larvae is trying to penetrate, the intestinal wall or the stomach wall, or once penetrated, just migrates a bit in the abdomen, you will have clinical symptoms related to that. But they also represent allergic problems because in the larvae you have several types of allergens which can cause minor to severe allergic problems, even up to anaphylactic shock. You can get these by ingestion of the worm, but also we know now by inhalation or by skin contacts. So We see an increasing diagnosis in fish and people. It is also a problem for human health, but also for fish health. We see reduced swimming capacities, we see reduced body condition, we see lesions to the stomach in the fish. It's of course also a quality problem of the fish meat. As you've seen here on the video, the larvae are a few centimeters long and some of them can be quite dark in color, so they're easily visible. Which represents the economic problem for the sector because they get a lot of customer complaints and they have to make sure that their fish is free of parasites before they put it on the market. So there are losses there as well. So some very rapid concluding remarks. So foodborne parasitic zoonosis are underestimated. We have a lack of adequate diagnostics. There is no real monitoring or reporting program. We do have a lack of knowledge both in the veterinary and the medical sectors. And we see with the globalization that they occur at unexpected places. We also know that what we know about the diseases is the tip of the iceberg. And so these are not negligible. They are very important and we should work more about them, try to prevent and to control them better. But therefore we need better diagnostics, but we also need better guidelines and better recommendations and monitoring and surveillance system. We need to bridge that gap in knowledge, both for the vets and for the medics. And we need to know more about the actual sources of infection. So this was the end of my presentation. Thank you very much. I will leave the word again to Hien. Thank you.
Okay, thank you, Sarah, very much about the whole picture of parasite disease in the world. And maybe we underestimate the importance of parasite disease. So we have about a couple of minutes to have question and answer. So can anyone, if you have question, you can turn on the microphone and just talk, or even you can type on the chat box so I can respond, or other people can share the knowledge and also answer the question. So please. Yeah, just turn on the microphone if you want to have the question. Yeah, because in the next session, maybe we don't focus what Sarah mentioned again. So if you have a question right now, you can ask the question. I think you have some questions.
Please go ahead. Or if you have a question, you can always send me an email as well. I will put my email address in the chat, but don't hesitate. There's no stupid questions. There's only stupid answers. Okay.
Yeah, so if you have more questions, so you can send email to Sarah in the chat box. So she wrote the email address. Okay. So one of the important, sorry, there's someone.
Yes, actually, I have a question for Professor Sandra. That what are you focusing on the research in your university? I mean, in your laboratory.
Okay, thank you for your question. I focus on a number of parasites. So for Belgium, I do a lot of work on Anisakidae and Sarcocystis species, but I've also worked on Trichinella, on Echinococcus, on Fasciola. Now for the south, well, in Vietnam, we do also focus on Anisakis, but also on Taenia solium, Taenia saginata. I have a lot of projects also in the African setting. So quite a number of parasites, in fact, yes.
I see. Thank you so much for your answer.
Okay, so that means Sarah worked with many kind of parasite. It depends on her project in Africa, and she also did some project in Vietnam also. I think we have the last question. I think so. Do you think about the report data in Vietnam, especially on Tania Studium?
Yeah, I think it's a good question. Now, we have done some work in Vietnam, and Tang will talk about this later. I do think that in all countries there's underreporting because wherever we do a study where we use more in-depth techniques, we do find quite a lot more than what we expect. You have to see that mostly the reporting specifically of Taenia solium is done like at slaughterhouse level, but then it's based on meat inspection, and meat inspection has a very, very low sensitivity. So most infections will be missed and will not be recorded and will not be reported. From a human level, yeah, it's a bit the same. It's you really need neuroimaging, so you need CT scans if these are not done, if actually the cause of epilepsy is not thoroughly investigated, then you will not know it's Taenia solium. But I do think that on a human level in Vietnam, the system is much better than in the African setting.
Yeah, I think the problem with the parasite disease that the disease appear very slowly. It's not look like viral disease, so that's why maybe underestimate.
Absolutely, yeah. Some diseases take years to come, like with Echinococcus, it can be 10, 20 years before you see symptoms.
I think we don't have more time to have some questions for you, but you can look at the chat box. There are some questions you can answer
in
the chat box. Yeah.
Okay,
so one of the very important number I saw in Sarah's presentation that among 31 the important football disease, 14 is parasite. I'm absolutely there are some area some parasite important, but another one might be different. So what is about the problem in Vietnam? So maybe we go to the next speaker. So may I introduce Dr. Thanh to have the presentation about the parasite in Vietnam. So what is the most important one and what we should consider? So please welcome Dr. Thanh. So you can share your screen.
Okay.
Okay. Yeah, I can see it.
Can you see my screen? Clear?
Yeah.
Can you hear me enough?
Yeah, very well.
Yeah, thank you. Good evening. Welcome you all to the workshop on foodborne parasite zoonosis are they regulated in Vietnam. My name is Thanh, a parasitologist from NIVIA Vietnam, National Institute of Veterinary Research. Parasite and zoonotic parasites are still issued as a country for both diversity of parasitic species and its prevalence. Today, I would like to talk to you about status of parasitic disease in Vietnam, with some focus on foodborne parasitic zoonosis. In this presentation, I will review some important foodborne parasites in Vietnam. I will go through 4 parasite groups. First, fish-borne parasite group that can be transmitted by eating raw or undercooked fish. Second, fish-borne parasite group. Meat-borne parasite group that can be transmitted by eating pork. And third, waterborne and plant-borne parasite group. The parasite transmitted by fecal contamination of food and drinks. And fourth, STS, soybean transmitted helminth group. From each group, I will briefly discuss some of the most important species that's occurring in Vietnam. Those are Orbitoctis viverrini and Chlorochis sinensis for fish-borne parasite group, Trichinella and Taenia species for meat-borne parasite group, Fasciola and Jactia species for water pond and plant pond group, and Toxocara species for STS group. Firstly, with fishbone parasite group, here you can see three the most important zoonotic member of fishbone trematose. Its life cycle involves to snail and freshwater fish. The parasites are ingested by snail intermediate host. The Saccharia will be released from snail attached to fish host and develop into metasaccharia. Infected stage upon the ingestion of infected raw or undercooked fish. The metasaccharia then invade human hosts and other mammal hosts. In Vietnam, there are two zoonotic species of Orbitocys viverrini and Chlorolochis sinensis are reported. The number of infections were estimated at 2 million. Among endemic countries of the fishbone fluke, Vietnam is a unique country is recorded with both species, but in separation of geographical part, Chlorolochis sinensis is prevalent in the north and Orbitocys viverrini is prevalent in the south of the country. The main risk factor associated with the infection were determined as consumption raw or undercooked fish, living on fishing or living nearby stream and have no sanitary toilets, of which eating raw or undercooked fish is a key risk factor of the infection. Chlorolochiasis in Vietnam prevalent in the northern part of the country. In the past, there were two hotspots in Nam Định and Ninh Bình provinces of the northeast. Recently, a new hotspot was found in Thác Bà Lake of Yên Bái province, the biggest artificial lake for hydroelectric in Vietnam. It squares more than 23,000 ha, with the length of the lake is 80 kilometers, and population living around the lake is 250,000 residents. The residents around the lake mainly live on fishing abundant fish from the lake and have routine eating raw fish. In addition, not only fishermen defecate directly into the lake during their fishing, but the residents living around the lake also defecate directly into stream or toilet waste or directly into the lake, though activities resulting in prevalence of Chlorolochis sinensis in humans around Thác Bà Lake is typical highs, reach up 60%. As well, infection rates of Chlorolochis sinensis in reservoir hosts and intermediate hosts were typical highs. It's 45% in dog and cats and 90% in fish hosts. Different from Chlorolochis sinensis, Orbitocys viverrini in Vietnam is only prevalent in the central and the southern part of the country. Prevalence of Orbitocys viverrini is quite lower in comparison with that of Chlorolochis sinensis in the north. It is around 11.4%. It may result from special way the local people over here eating raw fish. Raw fish only serve live and several times a year during February. Local people believe the ZFP in this time is the soft and the best for health. And by serving the whole live fish, so only men can serve more with during while. Explain why no women and children got infection with Orbitocys viverrini from our investigation. And now we move to the meat-borne parasite group. In Vietnam, major meat-borne parasites are Artemia species and Chikungunya species. Human get infection by eating raw or undercooked meat infected with this stage of these parasites. name chua, and name. Measures are taken to prevent humans from becoming infected with meat-borne helminth by inspecting the meat in the slaughterhouse or laboratory. Tenia in Vietnam prevalence in 61/64 provinces, except Quảng Bình province in central part and Bạc Liêu and Sóc Trăng provinces in southern part of Vietnam. Average prevalence is typically low, around 0.9% in pig and 5% in humans. The main risks of infection in humans were identified as eating raw or undercooked pork. In early 2019, an outbreak of teniasis was found in Bắc Ninh province nearby Hanoi capital. Exploring out from discovery Teniasolium contaminated pork at the kitchen of a kindergarten. Chickenella is a widespread zoonotic pathogen, and the occurrence of chickenellosis in Vietnam is strictly related to cultural food practice, including consumption of raw or undercooked pork. There have been 5 outbreaks of chickenella taking place along the country during last decade, mainly in the northeast and the northwest mountainous provinces where people have routine eating raw or undercooked pork. In each chickenella species were at risk of 8.7% in humans, of which 8 people were died in outbreak in 2012. Reservoir hosts were confirmed as white boar and rest at risk of around 3%. Recently, some sporadic small outbreaks taking place somewhere in remote and mountainous areas along the country. Chickenellosis is not only a public health hazard, but also an economic problem in porcine animals production and food safety. Water is a major vehicle for many environmental states of parasites. A common infected route is by drinking water, but infected states may also contaminate fruits, vegetables. It's often difficult to associate an outbreak with a particular food item, and therefore also difficult to identify how the foods became infected. Because of this, the acquisition of the foodborne routes is almost certainly largely underreported. Among emerging waterborne parasitic infection in Vietnam are Giardia species and Fasciola species that will be briefly discussed here. The most important public health member of plant-borne parasites is the Fasciola species, including Fasciola hepatica and Fasciola gigantica. Its life cycle related to aquatic snail and aquatic plants. Fasciola in Vietnam, fasciolosis in Vietnam caused by Fasciola gigantica is primarily in a parasitic infection affecting the livestock sector, resulting in economic loss. However, human infection seems to be more common than previously accepted, and human fasciolosis is emerging in central Vietnam, where flooding taking place frequently during rainy season of the years. And the people here have routine eating raw aquatic vegetable and drink unboiled water. These river fluke were high prevalence in both cattle and human, at risk of 60% and 27% respectively in 2 hotspots of Hồng Delta River in the north and central Vietnam. More attention of this river fluke in Vietnam by its hybrid form between Fasciola hepatica and Fasciola gigantica were found in both in central Vietnam. Other zoonotic protozoa of waterborne parasite group is the Giardia species. Giardia in Vietnam were found in water animals, vegetables, and humans. Prevalence is the highest in cattle and water samples. However, prevalence of this protozoa is low in children, less than 5%. Both Giardia and Cryptosporium represent a challenge to safe drinking and recreation water supplies due to their resistance to chlorine and environmental resistance. ATX group soil transmitted helminth. I would like to talk about the Toxocara species that can cause visceral larvae migrants or toxocariasis or ocular larvae migrants or LV are present in Vietnam with Toxocara canis to be predominant in dogs and Toxocara cati in cats. Recently, Toxocara malaysiensis previously reported in China and Malaysia were reported in cats in Vietnam at the first time. Eating raw vegetables that growing in low sanitary area and to be fertilized by pig fecal can be get infected with the disease. Foodborne parasite zoonosis are still issue in Vietnam. However, it should be neglected disease in the country. Recently, some decision and regular related to the national control helminth from Ministry of Health are issued. However, non-national helminthic prevention and control program for animal all are focused on virus and bacteria. A food safety law seeks to improve quality control of slaughterhouse and processing facilities within food distribution network. However, parasite zoonosis did not be paid enough attention. In early 2019, in a pilot field trip for this project, we visited Raho and Institutes of Public Health around Ho Chi Minh City, and we did find a big gap between parasite zoonosis and other zoonosis, such as virus or bacteria or chemical residue. Parasite zoonosis are really limited in both the diagnostic technique, monitoring, and reporting. The rise in general public concern over security of the food chain and food safety have helped to focus more attention on zoonotic parasites. However, for many of zoonotic parasites, the system for routine diagnosis, monitoring, and reporting are inadequate. As a consequence, the incidence of human disease and parasites occurring in food is underestimated. Re-emerging of many parasites therefore often seems that the result of improved diagnosis and reporting than of the real increase. Yeah, thank you for your attention. That's my talking, and now I send word to Associate Professor Hiền. Yeah.
Okay, thank you, Dr. Thanh. So I think we have a few minutes to have a question with her. So everyone, if you have a question, just turn on your microphone or type on chat box. think there's one question. You can turn on the microphone to talk. It's okay. Okay, we have one question. Tan, you can have look on the chat box. So there are the question to ask about the risk when consume the salt water in Vietnam. Yeah.
Yeah, thank you for your question. Actually, until now we don't have any data on risk when you consuming fish living in the salt water. Actually, I do a lot on liver fluke, and for fish born with the liver fluke, we don't have any data on that. But for other nematode, I don't have any information on that.
But I'm really sure that anisakis also a risk when you consume saltwater fish, right?
No. So actually, it's in risk. We should not eat with the raw or undercooked fish to protect ourselves from parasites, zoonotic parasites.
Yes, if I can add on to that, as Professor Hien has said, we've started looking at anisakis in fish, and we do find them.
Yeah. So because normally people just think that the salty water fish is not important for the parasite, but we do find that, right? Yeah.
Yes.
And the question from Lam, he asks, can we see chlorpyrifos in southern Vietnam? This is a big area of river too. Actually, for the chlorpyrifos, we just find in the north of Vietnam. It belong to the Hồng River. For the south of Vietnam, it's the Opisokis vivacini is belong to Mekong River. Sometimes you may find with the Chlorolochis sinensis with some people in the south, but actually they didn't infected from the south, but infected from the north, and they just moving to the south. We until now we don't have any clear answer for that, but for small liver fluke, for Chlorolochis, yes. Chlorolochis sinensis and Opisokis vivacini, they seen prevalence very similar with the geography areas, the not mixed.
Yeah, I'm really sure that we don't have a lot of data for different kind of products. What is the percentage of infection? And they have one question about the prevalence of, so it's going to be high. So do you have any comment on that?
For the in Bai, Chlorolochis sinensis prevalence in Bai province around Thác Bà Lake. I and Nimbe do survey in several communes. We this use cartocast to test to examination the egg of Chlorolochis sinensis. Then we how I can say. Then with the positive case, we give them with the praziquantel treatment. Then we I forgot.
Yeah, I think the prevalence seems to be high. It depends the way you collect the data and you choose the sample. So somehow when you local the sample in some area, so the percentage may be high. But if totally random, maybe it's smaller. Yeah, it depends. Yeah. Okay, I think we have one question about fire anisakis in marine fish, new public. Yeah, I'm definitely. So that's why we will move to another the third part when we're talking about anisakis, the how do we found how we detect it in marine fish. So I think we have don't have enough time for questions. So if you have question for Dr. Tan, you can type on the chat box, and Tan, you can send you can answer directly, or you can would you please to put your email on that, so people, if you they really interested in the number or the information, so they can ask you directly.
I can put my email over here. So if you have any questions, you can send directly to me.
Yeah, thank you. I can see a lot of questions will come up. Yeah, I'm sure that we there are many data we don't have, so that's why the project done in Nông Lâm University with Ghent University. So we try to emphasize on the south of Vietnam to understand, because we did before. I think that they have another project done before in the north, so in the south we don't have enough information. So that's why we focus on the data on the south. So and during the project, we found one interesting, that is we found anisakis in marine fish, as one of the participants mentioned in the chat box. So very important, very new one for us. So our team want to share the method we use to detect anisakis in Nông Lâm University. So I would like to introduce Miss Mai. So she will present the way how to detect the anisakis in Nông Lâm University. So please welcome Mai. So one point, because the workshop, we try to invite people to go to the lab to work in the real sample, but because COVID-19, so we couldn't do that. So that's why the group tried to make the video, and I think Mai can explain a little bit about the video, and then we can watch the video how we did that, and then we can have some question and answer later on.
Yeah. Thank you, Professor Hiền. As Professor Sarah and Dr. Tan mentioned about the different kind of foodborne parasitic disease in not only in Vietnam but also on over the world. And in our project, we also work on different kind of parasite as fishborne or mistborne. And in this video, we are going to introduce a technique to detect parasite from animal tissues, and the one I think it plays an important role we would like to mention today is anisakiasis. The genus of anisakis are common parasites of marine fish with a worldwide distribution. However, this zoonosis is still a new story in Vietnam. Due to sea fish intake, anisakis may affect the human digestive tract after consumption of raw or undercooked seafood containing viable anisakis tusk larva stage. And in this short video, it shows the life cycle of anisakis and how we collect and identify the tusk larva stage of anisakis from marine fish in Vietnam. Now, let's watch the video.
The larva stage of nematodes of Anisakidae family, parasitized fishes, cephalopods in streams, and the Anisakidae adult swarm, parasitized fishes, marine birds, and mammals. The larvae of genus Anisakis and Pseudoterranova, if ingested by humans, are responsible of a disease known as anisakiasis. Larvae obtained from human patients or infected hosts can be morphologically identified. However, larvae of genus Anisakis and Pseudoterranova can be distinguished. Molecular methods based on the PCR RFLP allow the identification at the species level of single larva of Anisakis subspecies and Pseudoterranova subspecies, in particular 7 species of Anisakis. The species of Anisakis and Pseudoterranova differ in the composition and/or size in the DNA sequence of the locus ITS, internal transferase spacer, allowing the unambiguous identification of all epidemiologically relevant Anisakidae. Sample preparation. Prepare a container of 2 liters of water preheated to 44 degrees Celsius. Place the container on magnetic stirrer. Gradually decrease the stirring speed. Adjust the water temperature to exact 44 degrees Celsius. Use a 10 mm pipette to drop 8 mm of hydrochloric acid 25%. Add the pipetted hydrochloric acid to the rotating water. Weigh 10 grams of absinthe from its container. of whey pepsin. Add the whey pepsin to rotating hydrochloric acid solution. Maintain the whirlpool until the pepsin completely dissolves. Set the incubator at 44 degrees Celsius. Incubate the fish at 44 degrees Celsius for 1 hour. The fish after 1 hour of incubation at 44 degrees Celsius. Enzymatic digestion. Remove brown warm lava from the fish liver surface. Place the lava on a petri dish filled with a small amount of water. Weigh 100 grams of fish fillet. Put 100 grams of fish fillet into the prepared hydrochloric acid pepsin solution. Maintain the temperature at 44 degrees Celsius. Wait for 15 minutes. The fish fillet dissolves in solution after 15 minutes. Pour the container through the sieve placed on a 4-liter container. Use tweezers to take lava from the sieve and put on a petri dish filled with water. Dry warm lava removed from the sieve. DNA extraction by tackle device. Process the sample. Grind the lava into small pieces. Collect the processed sample into a 1.5 mm tube. Transfer the processed sample into a tackle DNA extraction kit. Follow the manufacturer instruction. Use 20 microliter of sample solution. Turn on the device. Place the comb and extraction kit with the lava solution. Press the start button. After extraction procedure, open the door and take the kit out. Collect the extracted DNA in a 1.5 mm tube with a pipette. The DNA can be stored. PCR amplification. Prepare 10 micromole of NC5 and NC2 primers prior to the procedure. Need 18.75 microliter Gotek G2 at 12.75 microliter nuclease-free water. Add 1.5 microliter of NC5 primer. Add 1.5 microliter of NC2 primer. Transfer 23 microliter of a newly mixed solution from PCR mixed tube marked as negative into a new tube marked as PCR. The remaining amount in tube negative is used for negative control. Add 2 microliter of the extracted DNA into the marked PCR tube containing 23 microliter of PCR mix. Start a PCR machine. Put the tube into the device. Put in the necessary parameters. Startup amplification cycle. After cycling finished, open the device. Take the sample out. This ends the PCR procedure. Prepare the chemicals and sample for electrophoresis. Load the sample in each well. Run the gel for 45 minutes. Wait for the results. Read the electrophoresis results. The size of fragments expressed in the nucleotide base pair number produced by the amplification are shown in Table A. In Table B are reported the ITS digestion fragments obtained by enzymatic digestion with the specific enzymes.
Okay, so I think that the video is covered step by step for the detection, but because of the bandwidth and the transmission of the internet may be slow, so maybe you cannot see very clearly. So I will post here the link, YouTube link, just so you can rewind and you can see the video later on. So we can have one question about just general about the. I think because we don't need to go very detailed about technique, because if anyone really concerned about that, you can send email to ask her or to discuss her about that. So please welcome just one question about just general. Yeah. Okay, so any questions? Okay. So normally we think about parasites, people just think about morphology, but in this study we use a molecular technique to detect parasites. So that is something changed in the regular thinking about parasite disease detection. So if anyone have any questions, so please welcome to ask our group. Okay, thank you for the question. So Mai, can you answer the question? Hello.
Maybe it takes 1 or 2 days for the whole procedures.
from the DNA extraction, collect larvae and pizza and nutrition enzyme. I think 1 and 2 days. Can you hear me?
Yeah. Thank you. Yeah. Yeah. So normally after detect the anisakis, we need another step to use enzyme to cut the DNA and then to find out which species. Yeah. Right now it's just start. Yeah, just start. So if you have questions, just send email to Mai. So can you put the email address here so people, if they concerned about, they want to have more information about the procedure, so they can send email to you. Okay, so thank you very much for the sharing technique. So now we move to another part about the discussion, the general discussion, panel discussion, how we collaborate. So that's why in order to control parasite disease, so you can see that there are the connection between animal health, human health, and also environment. So that's why we bring many aspects to the discussion today. So the first one, I would like to invite Dr. Thong, Professor Thong from Nông Lâm University, so in the Faculty of Animal Science and Veterinary Medicine. So we would like to understand what the role of the university in contribute into this arm or this purpose to control the disease, or what did we already do in the area of parasite disease control. So are you there, Thong?
Yeah, I'm here.
Yeah. So
thank you, Professor Hiền. Good evening, everyone. So thank you for everyone to join the workshop this evening. So thank you the very nice presentation from Professor Sarah, from Dr. Tan, and from Dr. Mai. So thank you the organizer to give me the chance to share information on genetic disease control in our faculty. As the role of the dean of the faculty and having much attention on the teaching program, I have some points to share with you. The best student in our faculty have at least 2 courses of the parasitology, in which focus much on the biology and the production of parasitological disease. In addition, we train the best student genetic disease course in the curriculum, with more information on parasites, especially the one we can transmit by the food and the meat, and so the one that considered as the occupational disease. Another course we call public health. He also focusing the foodborne disease and the meat inspection, and give the students chance to observe parasitic disease in slaughterhouse. So our students have been supplied some background knowledge and the skill on the parasitic genetic disease. Admittedly, number of the research on parasite in our faculty is limited due to the overestimated consequence of the microbiological populations. The research on parasitology not only focus on the morphology, but also apply the molecular technique to have deeper understand about them and reveal their importance and open the more opportunity for the research collaboration. So example for the case of Dr. Mike just presented to you. So recognizing the importance of the genetic disease and the food safety, our faculty try to open the master program in vet public health, and we plan to start for the India this year. So this will make the link between the human health and animal health. Thank you.
So thank you very much for sharing the idea about what we do, what the faculty did to understand or to research on parasites. So that is the angle view from animal science and animal health. So we would like to hear from human health, because normally we say that protect disease in animal health is the way to protect human health. So in that case, I would like to invite Professor Phong from University of Medical and Pharmacology in Ho Chi Minh City. So where are you from, Professor Phong?
I'm here.
Okay, so can you
Thank
share
you.
with us anything about parasite disease research on your institute and your study in your university? Yeah. So you can share by screen share. Yeah. Okay.
Yeah. So I think, wait a minute. Thank you, but
yeah, I can see the screen. Yeah.
Yeah. Thank you, Professor here, and thank you, the organizer, for the inviting me. So, as a doctor, I am working in hospital for tropical diseases, and we have in cooperation with Oxford University about the infection of central nervous system, like meningitis and encephalitis. And today I would like to shortly talk about the eosinophilic meningitis in patient treated at the hospital for the tropical diseases at Ho Chi Minh City. So our presentation briefly divided into 3 parts about introduction, and we are talking the case of eosinophilic meningitis by Ankylosaurus cantonesi, and I think we for this problem we need cooperation. We need in cooperation with veterinarians. And as you know, this parasite is an endemic in the Southeast Asia, and especially in the recent years, the human case have been reported from increasing at diverse locations. So we know about the host of this parasite is a rat, but humans are frequently infected by direct injection the raw snail, and especially the in the Mekong Delta. So the people have they can they eat usually eat the raw snail with the lemons or with the mustard, and this we in the hospital we we received the 22 years old the patient. He's a student, and on admission the patient had a fever, confused, and he had Meniere syndrome. So we asked the friends of this patient, and we know about the 10 days before admission, this patient shared with a friend raw snail, because this is the it's the raining, and they had collect together in the dormitory, and he take a beer with some meat, and suddenly they saw the snail, raw snail, and they take raw snail, and after that they have fever, confused, like the symptom at the ignition. And as in our hospital, we take the lumbar puncture to check the CSF for the laboratory. And in the laboratory, we found that in the CSF, we found that the eosinophilic, this is the case of eosinophilic meningitis. So finally, we have the diagnosis meningitis by angiosyncytial cantonesis, and this patient has a very severe situation, and he stayed at the hospital during more than 2 months, and after that he needs stay at the at home to recover fully. So this is the case we can sort usually in our hospital, and usually we receive the patient from the Mekong Delta. So for this problem, I think we need share the information with our colleague from Nông Lâm University, from
I think the connection from Dr. Phong maybe has problem, but at least he just looked like showing a real case, and to show that the case, you have to look at the different angle from human health, animal health, and also in the environment. And it's basically those kind of disease, animals act as the reservoir for those disease. For the next panelist, I would like to introduce Dr. Nguyễn Văn Dũng. He worked for Sub-Department of Animal Health in Ho Chi Minh City. So we can hear from him about how the government control the foodborne disease and how they manage, and the real story maybe from him. So Dr. Dũng, can you just turn on the microphone and just share with us what the government do to manage? Okay, Dr. Dũng, can you do that?
Thank you, Professor Hing. Can you hear me?
Yeah, I can hear you. Yeah.
Sorry.
Hello.
Hello, Dr. Phong. Do you want to speak a little bit more?
Yes, yeah, just one more slide.
Oh, okay. So go ahead. Sorry, Dr. Dũng. Yeah.
For the connection. So about this, so again, this last slide. I'm sorry for the connection, not good. So I think for this, just one of the disease, zoonotic disease, we not much have more the research about this problem, and we need cooperation with our colleagues from our colleagues, the veterinarians, and we must share information together, do the research and training course. And of course, as you know, we have 7 core, one have 7 core competency, and about the culture and beliefs. You can see this. The usually we see that the patient from the Mekong Delta, so they have the habit to eat raw snail. So this we usually for the medical doctor, we receive the patient and we think about the food that this patient eat. But for this problem, we must consider all the food supply chain, not only for the patient in the table, but for all the supply chain. So conclusion, I think for the parasitic meningitis is neglected disease in Vietnam right now, and we must consider this problem in food supply chain, and we must have the cooperation with on the stakeholder, on the another specialist, not only for the medical doctor, and we must apply the One Health core competency in this problem. And in conclusion, as you know, we have the One Health is working together, but I think we can develop to say that One Health is doing everything together. So thank you for your attention, and you can see I take this picture in our village in Long An province. This we can see many risks of infection, especially for parasitic infection for this person. Thank you.
Okay, so Dr. Phong really mentioned about human case, and he also worked for tropical medicine hospital. So that's why he had some real case like this. And one of the most important he emphasized that is the ensure food safety chain. So in order to ensure food safety, I think the government has to do something. So that's why we need the comment from Dr. Dũng. So how the government do that? And Dr. Dũng, can you turn on the microphone?
Oh, thank you, Professor Hiên. Oh.
Yeah, go ahead.
Okay. Okay. Good evening, Professor Sarah, Associate Professor Hiên, and participant. Today I would like to talk about prevention and control animal disease in Ho Chi Minh City. And first, I would like to introduce my office in a short time. So, Sub-Department of Animal Health of Ho Chi Minh City divide some division, and for example, animal science and epidemiology and vet public health. This is for control the animal disease and examination and food hygiene safety. So in Ho Chi Minh City, total of the animal in Ho Chi Minh City, for example, cattle, about 100,000 animal, and swine, and 150 animal, and dog and cat, and the poultry. So Rodas animal from Ho Chi Minh City only supply 20 food for consumer in Ho Chi Minh City. So, and 50% livestock products imported from the other provinces. So the animal and animal products transport from the other provinces. It maybe carry the many pathogens for coming to Ho Chi Minh City. So that we have to some the methods for the control the animal disease, and we have some program for surveillance of the animal disease in Ho Chi Minh City. For example, in the cattle, every year we surveillance the foot and mouth disease, brucellosis, leptospirosis, bovine tuberculosis, and plus parasite, for example, babesiosis. And in intestine parasite, we carry out from 2010 to 2015, and in the peak, we surveillance Lascigo swine fever and Africa swine fever, foot and mouth disease, swine influenza virus, and in the companion animal for we control the rabies virus and toxoplasma. We use the rabies package on the other disease. We use the bucket from the government. So in the poultry, we survey the Newcastle disease, avian influenza. So the surveillance is to provide early warning of the animal disease outbreak, and more than 95% package from the government used for the control infectious disease, for example, the virus disease and bacterial disease, and about 5% package from the government used for control the parasitic disease. So, and about the food safety and hygiene measurement, in Ho Chi Minh City, we have 13 industrial slaughterhouse, and in the slaughterhouse, we collect sample for examination chemical, hormone, and antibiotic residue. And we also examine of the microbiology contamination on the products. For example, the bacteria, we testing the Salmonella, E. coli, Vibrio cholera, and in the parasite, we only check for the leukocyte or post-mortem examination. And about collaboration in prevent and control the animal disease in the zoonotic disease, we already collaborate with the university or the institute in the human human health, and a foodborne parasitic zoonotic disease, and we only a few collaborate with the other university or institute. So that's we would like to have the collaboration with the other organization, for example, non-university or the university for collaboration to research on the parasitic disease. And I think some parasitic disease we consider, for example, trichinosis, bovine certificosis, and swine certificosis, and toxoplasmosis. And I think we can collaborate for research on surveillance of the foodborne parasitic disease in animal, or collaborate on research about risk factor assessment or molecular research on molecular epidemiology. And also we would like to collaborate for the prevention and control the foodborne parasitic disease. That is, thank you.
Okay, thank you, Dr. Dũng. It seems to be we underestimate and also don't remember the parasite disease, because I just say that Dr. Dũng said that just 5% of the budget going the surveillance of parasite disease, right? So it seems to be we don't really evaluate the real importance of the parasite disease. Maybe we don't have enough information, enough data to understand the importance of that in Vietnam. Maybe that's the problem. And also, as we mentioned before, parasitic disease, sometimes it's very, it not look like severe, you can recognize right away. And to control that and to understand that, maybe they have the many sectors maybe related to that, maybe environment, animal, human health related to that. So to control that efficiently, I think the One Health approach is a good choice for that. So that's why we invite Professor Dr. Phúc. So he works for One Health University Network in Vietnam. So this is very powerful organization now today in Vietnam. So please welcome Dr. Phúc, so he can share some experience or the real case about how we collaboration, and the collaboration can help us to solve the problem. Okay, so.
Thank you, Professor Ian. Dear Professor and our colleagues, can I share screen, Dr. Dũng? Can you stop the screen?
Sorry, thank you.
Okay. Okay, thank you very much. So today I may not expertise about the parasitic zoonotic disease, but in the general context, I bring the issue here, how we are working together. That's why we have a One Health approach. And I bring one case study. It's a really applies One Health approach to conduct this study. As you see that in our screen. Here it's a study including different research institutes. It's a livestock research institute and our research center in public health, Vô Hun network, of course, and it's a veterinary research institute, and it's a NIPE, it's a parasitology research. So here we conducted one small study in the mountainous area in Vietnam, actually in Hòa Bình province. So we focusing two specific zoonotic disease, it's trichinosis and cytosuchosis. So before that, I show you what our research center we established a long time ago, with more focus in environmental, agriculture, social, and it's economic linked to human health. And the network is a Vô Hun. Actually now it's a 24 university, including medicine, public health, agriculture, and nursing. We are working together and develop the One Health curriculum for students and existing professionals. So try to bring the new knowledge on One Health and competency for the future leader on One Health. So this is a case study with our aim to assess and reduce both parasitic tick-borne disease, or you call pork-borne disease or food-borne disease. Okay, but this project we call it parasitic tick-borne disease in the ethnic minority group people. It's some the key. It's a specific objective here. The first we to access prevalence of both cytosuchosis and trichinosis in pig and human. And the second objective here, we try to improving its capacity for diagnostic detect of both cytosuchosis and trichinosis. And we propose develop some kind of feasible or relevant intervention. As you see here, that's some of the key highlight our finding. We are conducted 3 years ago. We finished last year. Some of the key achievements from us. Actually, this study it really is One Health in action, with 3 research institute on public health and 2 research institute in vets. And it's an exchange, it's a north-south collaboration between Vietnam and Germany. we are going to face the university. The finding we found that to estimate the prevalence in the human is still it's low, less than 1%. Or more than 50 is a local butcher, and lab technician already changed diagnostic test and the knowledge and skill how to make the communication. And over there we focus, we have 20% of that female attended this training course. It's still a very risky. It's practice. It's a farm level. The people there still raising pig. It's free, roaming around the garden, and that is one very risky. The pig they infected some parasites, and also the human is still accepted about the risk. And more than 30 human health worker and animal health worker at the community and village level already trained on risk communication related about food safety, but focusing and cytotoxicity and tricellosis. After we conduct the training course, the TOT for both human health worker and animal health worker in the same village, in the same commune, they are conducted community campaign by themselves, and they did expand to 23 commune, and we expected around 40% of total population in the Bắc district. They obtained the knowledge information related about the two parasitic disease, and over among them it's 50% of female. So one is a very important. At the beginning of the project, we as soon as possible to engage with the local authority or local government. They are very strong. It's a connected with a different sector in the same commune. That's why we think that if we got a high commitment with local people or authority, it could be good for different sectors working together. And in the future, we're thinking that to link it as a project. We call the ZFP. It's still ongoing. Try to make a local brand pitch, branding to make the value chain to help the farmer to sell the brand pitch. And the last thing is the communication material. We already developed and sharing not only in our project partner, also we sharing to other working group like food safety working group in Vietnam on Hawaii at a regional level. And of course, here you see that when you conduct a research or study, you need to involve the student in both public health and vet student. They attend and to join this study together, and students have a chance to learn real One Health in a real context. So that's all it from it's a case study. It's the last slide I would like to show to you how it's our One Health activity in Vietnam at the moment. We're starting to conduct One Health activity in 2011, and we plan for until 2027. So as you see, that the One Health network is a whole, it's a key, it's a center. So we try to focus and develop the One Health curriculum to teaching for students. So based on the One Health workforce development, we started in 2011 until 2024, focusing with both student, faculty, and also the existing human health worker and animal health worker and environment. They provide more full range knowledge on One Health and practice of One Health. And for students, very important, the students, they learn One Health through the One Health Student Club and One Health field side. It means we are teaching for students at the field based on the real case, not in the class. So this will change the teaching method and bring the public health and vet students go study together and have a chance to interact between a lecture from human health, animal health together at the same time, and interaction with a local professional. So that's the way we go to really to One Health in practice. And behind that, our network also conduct selected such a case study, very specific disease, to develop case study to teaching students based on its environmental and sanitation issue or food safety, food security, antibiotic use and antibiotic resistance, and selected some specific zoonotic disease and infectious disease. And of course, now we started a new project with focus at the wildlife disease. So wildlife consumption in Vietnam, it's been checking and checking, and people they can eat and consume its wildlife everywhere. It's illegal. So the government is difficult to control. We see that many germ hazard and pathogen they can spread from the wild animal to domestic animal also to human. So in this project to help to bring how different sectors working together and propose strategy to prevent it stop the spillover. And one thing is very important. We didn't mention before a lot about the One Health approach. So how it's a politic solution. Now it's a big issue in all the world, not only in Vietnam. But can we apply the One Health approach? For me, of course, we need to work about that and thinking it NCD and as a health issue. So for working, we need engagement with the community and actually the government agency, as I mentioned before, and it's a competency, it's a communication and a leadership. It's a key competency for the One Health, how to working together, how to engage the gender of female more linked. It's a project. And the last thing we see that biorisk management. So the hazard of biological hazard is everywhere, not only in the hospital, in the clinic, in the farm, or in a slaughterhouse, in the community. So actually for students, when you come to the community for study, so you have chance to bring some hazard back and forth to the house and the community. So it means that you need to provide more knowledge and skill how to manage the risk from the biological hazard for students, also even the student staff. There's a last thing is how the climate change and a lot biodiversity it can apply One Health. For me, I think it's really One Health topic. So maybe you can start to develop some case study, very simple, to make the people really to understand why we need to work together to protect or prevent the climate change, and by on that can develop a One Health curriculum to teach it for future workforce. And the last thing I think that is all from my side. I hope that you capture on One Health approach, and not only for the zoonotic disease, parasitic zoonotic disease today, but you can see more broader, can apply One Health in different health issues. So thank you very much for attention.
Okay, thank you, Dr. Phúc. So he really mentioned about the case research and emphasize on One Health approach using for showing the problem, and collaborative issues is the most important one. And he also mentioned about how One Health approach apply into the preparing workforce for Vietnam by using many collaboration. So it would really promising for Vietnam in the future when we dealing with zoonotic disease. So it's a good picture, right? So now we open for anyone can give any comment, any sharing experience, and also contribute into the discussion about how we collaborate to dealing with zoonotic parasite disease.
Excuse me, so may I speak something, Dr. He?
Yeah, sure.
Yeah. So I think this seminar very important and very necessary. And right now, so we see with our own presentation from their own speaker tonight. So the importance of the football parasitic zoonotic disease, and the most important that the One Health approach. So right now, so we have the more and more the infectious disease and the emerging disease. So that's the reason I think we need the collaboration in the education, especially for the postgraduate, because for the undergraduate. So right now, by the Google, so we put some course already for the vet medicine and for the human medicine, but especially for the postgraduate. So we not yet have the program. So that's the reason the Faculty of Animal Science and Vet Medicine in Nong Lam University, we developed one master program, that vet public health program. That's the first one in Vietnam. And I think that's a good point to prove that the collaboration between the human health and the animal health. And we asked for the collaboration for the international institute as well, example from the Queensland, and I hope that in the future with Professor Sarah as well from the Ghent University, because we need to build the workforce in the One Health, and the people who work for not only for the university, but the people who work for the government and in the practice as well. So I hope in the future, so we can have more the students to study this program, this matter.
So thank you very much for sharing that. We have the official program in Master of Pet Public Health to educate and also to have the high quality or high educated workforce working in collaboration in One Health. So thank you for that information. Do anyone have other idea or other concern? I have to notice that we have one people from Parasite Institute. I think I could invite people from, I don't know who I have, but I remember we have one from malaria or some Parasite Institute. So can you say any comment?
Okay, are you hear me?
Yeah, I can hear you. Yeah.
Yeah.
Introduce
Okay.
yourself.
Thank you, Professor here. I'm from the Institute of Malaria, Parasitology and Entomology, Ho Chi Minh City. So thank you for on presenter. It's a very interesting and it's a very informative meeting. So for me, it is very important to control the parasitic foodborne disease. So in my institute, currently we have the project on the Toxocaracanis human infection, because we usually see many patients came to check whether they get infection with the Toxocara SPP or not, and we only have the usually we use the ELISA test and the clinical sample to diagnose those people. However, almost the commercial diagnostic test we have, this import this from the outside, so that they use the patient, not Vietnamese patient, to evaluate those tests So the technically the OD value or the cutoff value is so different. That's why we usually see it in the high prevalence of people get with the high OD value. So that's why we want to develop on our test. So use the recombinant protein to evaluate the toxocaracanis or toxocaracati for the human infection. So this is very important for us to have the collaboration with the experts in the animal health to solve the problem, because actually in our case we have the like the patient, but we are not really exposed with the parasite from the animal. So this is the good chance for us to do the collaboration. So through this meeting, I get the very important information, and I can have some contact from the experts from all the university and from the institute. So I hope in the near future we can have the some contact each other and discuss some information, and can apply some we can discuss about the idea and develop some proposal and apply to get some funding. Thank you very much for all.
Okay, thank you, Dr. Minh-Anh, for sharing that. The difficulty when the one organization work alone for research or for control the disease. It seems to be that each organization is carrying a piece of puzzle. So why don't we sit together and to make the whole picture from each puzzle like that? So collaboration is the key success for any kind of work, not only the disease control, right? I think that we that I hear that some people want to talk, so we can. So I would like to invite you. Just turn on the microphone. Okay. I think the time is really over 9 already, so it's too late right now. So before we closing, so I would like to invite Professor Toang to summary and to give some feedback. I mean the take-home message from the workshop today. So Dr. Toang. So
yeah. Okay. Yes. Yeah. It's very nice workshop tonight. Now I turn back the last session. Actually, we have 2 hours with a lot of useful information. Actually, I learned a lot from the speakers, especially you share information and new updated knowledge to everybody. So very useful. So I would say to go to the end in the party of the end and take home message. Based on the presentation, sharing case study, we recognize that parasitic zoonotic disease are often in incidence. So very important and should not be neglected. Especially, it's really underestimating and non-information about parasitic disease in Vietnam also. In particular, in this day, the world is very close. There is connecting, and many activities as concerned or complicated, especially in the Sarah presentation. She also mentioned this issue. So the world is very small, so that's why really make a chance to develop parasitic disease around the world. So that's why research and practice to control this disease should be emphasized. Controlling in animal can reward on the protection on the human. So that's the key point. Really important. We focus on the One Health concept. So tonight we also discussed about that. And the discussion helped us know each other very well, understand how each party contribute their effort to the control or prevent the disease. So the successful strategy is that the collaboration among university, institute, or other organizations, especially animal health department, medical health department, etc. So even though in this case we make collaboration as a broad One Health concept, because this day we really emphasize One Health for human health, animal health, and environment health. So based on this workshop, I believe that we will make good collaboration and comprehensive among us locally, not focused in Vietnam, but also other countries. So very nice event tonight, very fruitful discussion. So last but not least, I would like to close our workshop now and hope to see you soon in person very near future when the COVID-19 is over. And Nong Long University is willing to welcome you come back to the next workshop in near future. So finally, one more time, I wish all of you healthy, happiness, and successful. Good night. Bye-bye, everyone.
So thank you for your participation. So I know it's very late now, but would you please to take your time a little bit to just give us some feedback? So I just post the link to give some feedback for us to help us to improve the workshop organization later on. So you can go to the link. I will give it in the chat box, and also you can scan the QR code to go directly to the evaluation and the feedback. Okay, so once again, thank you very much for your time, for your attendance. So see you next time.